Hi everyone, welcome to Snetly. In today's video, we are going to learn about how to generate PWM using Snetly. To generate a PWM, we require two signals. One will be your reference signal and other will be your carrier signal. Let me take from the Snetly library window. For carrier, I am going to take triangle. Here I am going to use my reference signal as a DC. So I am taking knob. We need to compare these two signals. So we require comparator block. Let us take from the logical module. To view the output, we need one DSO. Before connecting the pins, let us learn the technical concept how to generate a PWM. Here the basic concept behind the PWM generation. To generate a PWM, we require two signals. One will be your carrier signal and other will be your reference signal. For reference signal, we are using DC, and for carrier signal, I am using triangle waveform. We need to compare these two signals with a comparator, and we need to give a comparator logic. Logic can be different, greater than, lesser than, equal to, greater than, equal to. Here I have given greater than, equal to. So based on the input condition and the comparator logic, we will get the digital output, which is nothing but the PWM output. So for triangle, we need to assign minimum and maximum value plus triangle frequency. Similarly for DC voltage, then for DC voltage you have to give your voltage level. Here is the graphical representation to view clearly about the waveform logic. It is taken from the Snetly report desk. About report desk we will discuss in further videos clearly. Here we have taken 3 channel, one for your triangle and second will be your DC waveform and third channel will be DC PWM output. This will be your PWM output, and the axis of 0 axis for third channel here, remaining 2 channel 0 axis will be here. Red color will be your triangle waveform and green color will be your DC waveform. Here we have given the value of triangle 0 to 1 and for DC voltage around 0.75. Based on the comparator logic, I have given greater than, equal to. Whenever DC voltage greater than triangle, I will get a on time duty. If the comparator logic is false, we will get the off time duty. So I have kept at 0.75, so around 75% of on time duty and 25% of off time duty. Now let us implement this concept in our Snetly window. Based on the technical explanation, let us now configure the block and connect the pins. Right click over the block. Here I am going to use triangle as a internal control. For internal control, I need to assign my register value as 1. For triangle minimum and maximum value, I am going to keep minimum value 0 and maximum value 1. And your triangle frequency 2 kHz. Apply register value, then back to schematic. Now let us configure the knob value. Right click over the block. For knob minimum value, whatever the value you are keeping minimum, it will be minimum duty cycle, maximum will be your maximum duty cycle. So I am going to keep maximum duty 0.95, nothing but 95% of duty cycle. Apply register, back to schematic. Let us now view the waveform. Connect the output of triangle to channel 1 and knob output to the channel 2. Run the simulation. Here you can observe your triangle waveform. Let us trigger the DSO. Here you can observe your triangle 0 to 1 we have assigned in the configure window, and for knob the value is 0, so our output is 0. By changing the knob on real time, you can observe your output waveform is increasing. So up to 0.95 we kept it. Now let us connect the output of triangle and knob to the input of your comparator. Connecting triangle output to carrier input and knob output to the input pin of comparator. In comparator, we are going to assume the condition 1 is greater than equal to. That means whenever the amplitude of knob is greater than the triangle, we will get the output high, other condition output low. Connect the output to the channel 3. Here initially 0, our condition is greater than equal to. So equal to means this value as well as knob value as well as your triangle value is 0. So we are getting output pulse. By changing the knob value, our duty cycle is increasing. You can observe here. This is the real time duty cycle control. Now let us verify the condition greater than equal to. At first instant, you can observe from here to here, your triangle is greater than your DC, so our output is off. At this condition, our DC output is greater than the triangle, so we are getting on time. This is our on time percentage and this will be your off time percentage. In this video, we learned about the variable duty cycle control technique with a fixed frequency. That's all for today's video. If you have any doubts, please ask in the comment section. Thanks for watching.